through an individual metric, and then I will show the code in R. Like I'll kind of go through the code in R. And as I was going through this, I was like, whew, these are gonna take a while. Like I don't think this is something that you're gonna get through all of the metrics in like an hour. I think the other code, it was easy to just like copy and, you know, replace your park name. And if it was a NCBN park, it was a little, you know, different and you had to adjust for that. But otherwise, you just kind of like run everything. This is going to be a little different. You're going to have to make decisions about it, which hopefully is fun. And I think you guys are at a point where you're capable of doing this. As I was going through it, I was like, okay, I'm glad that we kind of waited to do some of these metrics and I didn't give this all to you in addition to all the other metrics. But looking at, so regeneration by composition, does everyone know what that map is going to look like? It's basically a pie chart that has like the most abundant species as individual colors, and then like you have to lump the rest, and we generally lump the rest by native or invasive.
I just put the in the folder metric examples. I just put these 5 ones there.
Oh, thank you. Yeah, because
I'll get the captions up too, but at least you guys won't need a caption for a few days.
Yeah, thank you. Thank you for remembering that. Okay, so basically it's the same starting point we have for like everything. So it's the join regen data where you use that code to just put the regen data together. When we're doing pies, it's just going to be the last 4 years of data. So that makes it a little simpler in some ways. And then the key here is to figure out what are the most common species, how are you going to lump, and then creating a shapefile at the end that has a row for every plot in a park, and then a column for every species group that you come up with. And then the values within there are, I think it's seedling density. Or maybe it's I think it's a combination of seedling and saplings together. So it's like all stems of regeneration together. So that's what you're going for. And I tried to write the code in a way that there was some logic going into it, like it was doing some of the work for you instead of like, I think when Camilla and I started this, we would just like open an Excel spreadsheet of like the data and like kind of hand figure out the species groups, or at least sometimes I did when I was just like, I don't have time for this. I just need to like come up with the groups and just like code out, or in Excel, like figure out which group I want for each species, and then have a column in Excel, create that group, and then bring it back into R. Like if you have to do that, that's okay. I tried to at least show a somewhat logical way to do this in code so that maybe it'll work for you too, and save you a little bit of headache and be repeatable. If you do it in Excel, it's a one-time shot, and if you have to redo it, you have to redo all of it by hand. All right, so the chunk that's this SPPDF, here what I'm doing is I'm creating a table. This is like summary tables in Excel, if you've ever done that. The table function in R is really helpful because it'll just like count up the number of records within like what you give it. So I'm making a data frame using the table function to come up with a list of every species in Richmond. And it is going to come up with a count for how many rows are in that species. It's basically, you're figuring out the most abundant species, and then it's arranging it by frequency. That's what the table function is going to give you in the output. And by arranging it by frequency, we see, in Richmond at least, Ilex opaca has the most species. And so that's one way to come up with like, what are the top 10 or so. And I think what we found when Camilla and I did this for NETN is if you have any more than 12 species, it's just like the colors start to get muddled because there are only so many colors that are contrasting. It's also busy on the graph, or on the map. So we want to try to keep it to 12 or less. I think 12 generally has been enough, and you don't lose too much information that way. But yeah, more than that, it's just not going to work. And it's possible you may have some parks that have fewer than 12, and that's okay too. Like Acadia probably has like 5 or something. So it's like all spruce and balsam and red maple. Yeah, there's nothing wrong with that. Okay, So I just wanted to mention, because I haven't really talked about the table function yet, but it is super handy. Like it's one way if you want to, you can summarize on one column, you can summarize on two columns. So if you wanted like Latin name and cycle or something, it would give you a table of species by cycle, and then it would have a summary. Anyway, so another kind of quirk about dealing with the data, so I'm on the make species code chunk. Another quirk about it is that our species name have spaces in them, you know, and so if we want to have a column for every species name, when there's a space in a column name in R, it's kind of annoying to deal with. You have to use tick marks to separate them instead of quotes. And then our QGIS doesn't really like them so much either, and it'll like abbreviate on the first word. And if it abbreviates on the first word and you have like two acers, then like it's hard to know which column. So I just created a function, make species code, that for every one of the metrics that have species today, we're just going to like start by making a species code, and it's a 6-letter code so that QGIS isn't going to abbreviate it. You're going to be able to distinguish across species. And because it's a function, you just use that make species code function instead of having to retype all of the code below it to actually make it. So you'll see it in action in a second. The other thing I had to watch out for, though, is that Acer saccharum and Acer saccharinum, if you just take the first 3 genus and species, they're the same name. And so I took within that function, just so you know that this is happening, if saccharinum is a species, it is saying change the species code to ASAC2. So in your data set, if you have ASAC2, that's a silver maple, not a sugar maple. And then it changed like the Quercus red group and Quercus white group to be more readable. Yeah, but this is just how you do it. And if you want to make species codes on your other, any of your other data sets, it should work if you have a Latin name and genus and species. Or no, actually, I created the genus and species. So as long as you have that Latin name, it should all work. And I think those are base R functions mostly. So. Okay, so just seeing that in action, the rich regen species, I just take that make species code function and wrap it around the data set, and it's basically just creating a new column called species code. Okay, this is where it gets a little trickier. I also, so this is just where like the kind of one of the philosophies of computer science or programming is do not repeat yourself. If you're going to use code more than 3 times where you're just like modifying 1 or 2 things, you should make it a function. And if you see that make species list chunk now that we're on, that's code. It's pretty short, but it was something that I was going to have to repeat like for every group that I'm trying to make. And so it's just like, oh, I'm just going to make this a function. So I made it a function again. So in this function, or sorry, in this code chunk, basically what we're doing is we're lumping a lot of things by genus. So especially in the kind of oak hickory forest, the big questions that resource managers have are about like how much oak is regenerating. And I mean, oak's species composition is interesting too, but it's really about like, is oak regenerating versus like beech? And ash also, you know, how much ash is there? And so it generally it answers a lot of questions just to look at genus level stuff. So what we're doing here is kind of creating lists of our species groups. So it's like taking the full Richmond region data set, and it's pulling out all of the like exotic species. So all the species that have exotic equals true. And then it's pulling out all of the hickory species, that's Carya, and creating a list of all of those, pulling out all the ash, creating a list of those, pulling out all the pinus, creating in their unique list. So it's just going to have those species on the list. And so that is going to help us to filter for a case win to create a group. So really all of this is leading to creating another column in the regeneration data set that just tells it which species group it's in so that we can group by and summarize on that species group. So it seems like a lot of extra work. Like as I was coding this, I was like, someone could probably do this faster in Excel, but I am going to try to code it logically as much as possible so that it's repeatable for you all. And I think these genus groups are probably, most of the parks will probably have most of these. Like, I can't think of, there's not probably another genus, Camilla, that you can think of that's totally missing. Like maybe Betula.
Well, you don't have Liriodendron or liquid ambar, which are pretty common.
Oh yes, so they get to stay on their own as their own
Oh, I
species.
see what you mean. Yes. Okay. Yeah. I don't know if Almus. Yeah, I got it now. Almus is probably not gonna be super. I don't know. You may or may not kick that out. I think it will depend. I think the Pennsylvania parks will have it, and then might not have it in Virginia. But yeah, I can't.
That makes sense.
Yeah, there's probably not another large genus.
Okay. Yeah, so right. I think I was leaving liquid ambar, Liriodendron, beech, and red maple on their own. Because it didn't look like there was really much other maple in Richmond, I guess.
There's not a lot of other maple, period.
Okay.
Valley Forge has some silver maple.
Oh, nice.
Yes.
Yeah. Okay. So these the genus groups that I used, I came up with them based on that table that I made, the species DF table. And so I saw that there was quite a bit of elm in Richmond, and there was quite a bit of pinus in Richmond. And so like I created groups for them, but right, you may find that there's like one ulmus or something, and so it's not worth doing for your park. So you've already kind of made decisions before you got to hear about which groups you probably want. And I think similar to how you guys came up with potential lists for, or potential habitat classifications for your maps and then like ran it by us, I think this is probably worth doing again, just to make sure that we're not missing species that are important. Okay, so after we come up with the genus groupings, the next is, so again, this is just like trying to use logic to do it instead of doing things manually. But again, if you end up doing it manually, that's okay. But the logic that I use, I'm at the code chunk that's grouped _ species. So I'm binding all of the lists that I just came up with, the genus lists, and also there's a low canopy list in here, which I think most people will probably want the low canopy list too. But I'm putting those all together in one table. And basically what I'm going to try to do is take all the other native species that don't make it on this list and that aren't in over 30% of the plots are going to be lumped into other native. And so this is a way to do it like logically in code instead of doing it by hand. If you do it by hand, that's okay, but it's just trying to do it. And also this is leading to, I want to actually make this into a function that does most of this work versus like having to hard code it. So I felt like it was worth trying to see what it looked like to do it this way. So when we're at the group species, that's a list of all species we already have classified as something. The tote number of plots, that's just to later calculate the % of plots that something occurs in. So then the other native is just going to be a list. It's taken from the Richmond regen data, and I'm grouping by species code, which is the species level. You know, that's like the 6-letter code that's not groups, it's species level. And I'm coming up with the number of plots, which is just the percentage of plots that something occurs in. And then I'm going to ungroup here. And then I'm going to filter by, and you notice the exclamation point before species code in the grouped species. So that's basically saying filter the regen data but only take in species that are not on that grouped list. So species that haven't already been assigned a group. I also don't want them to be exotic, so exotic equals false. And then I don't want to take the common species like Liriodendron, which was fairly common. And so this is the number of plots less than 30%. And then make species list is that same function that I used before. That's just making it into the same list. Yeah, Diana?
What does ungroup do? Like, what's the purpose of ungrouping it and then filtering it?
Yeah, it's you often don't have to do an ungroup, but if you notice, I did so what I did is I grouped by species, but I mutated instead of summarized. And so if you mutate, you always end up with the same number of rows that you started with. If you summarize, you end up with less. And so by it's still grouping, so it's counting up the number of plots for each species code, but it's gonna give each row that species code. So like Acer rubrum will be, if it's in 50% of the plots, it'll be 50 on every single one. And then I ungroup because I don't want it to just be working at the species code level. So it's kind of a trick with mutate. Like if you want to kind of if you want to assign somewhat of a summary value, I guess, to every row, but you don't want to end up with fewer rows than you started with. That maybe wasn't the best answer. But yeah, if you do a group by and mutate and you have pipes after that where you're doing other things, you're just going to want to ungroup.
That makes sense. Is that because mutate always has to go with group by?
No, summarize goes with group by. Yeah,
Right.
mutate generally doesn't. Mutate is just creating a new column to the existing data set. But by grouping by, it's actually calculating the number of plots for each species code, but it's still going to end with the same number of rows you started with. But it's because we have group by before mutate, and then we're doing other things that I wanted to ungroup. And I often don't use ungroup until like the R chatter is telling me like, you have a grouping variable unassigned, or I don't know, sometimes it'll just like, it'll warn you or like get annoyed that you're grouping, things are still grouped, and then I'm just like, ungroup, and then it solves the problem. So, okay. So that's how we created the other native lists. Again, if this is something that you do just by like looking at the data and you come up with the species codes that fit in that list, you can do that too. So then finally, what this is all trying to lead to is in the rich regen underscore species, which again, this is the same data set we started with in the beginning. We've just been adding columns to. Here, we're going to add another column. So that's with the mutate again, and that's species group. And then we're using this case when. Have we talked about case when yet? I don't think we have. So case when is kind of like if then or if else statements. So like if something is true, do this. If in R it's often like if else. So if something is true, do this. Otherwise, do this. And when you have more than like one or two if else statements, which this would be like, there's like 7 or 8 groups that we're trying to assign their species group to, it gets really long and hard to follow. And so case when kind of solves that problem. So here it's like a bunch of if statements, if else statements. So the first one is if the species code is in the list of low canopy species, then paste low canopy into the species group column. If it is in the exo species group, or sorry, if it's in the exotic underscore species group, paste exo species, and then just going through. And then if there's nothing else, like if there's species code that doesn't fit into any of those groups, paste the species code. And that's where Acer rubrum, Liriodendron, and Liquidambar just get their species code. And then this, again, table function, where I have table of the data and then the species group, it's going to tell me how many groups I have and then how many records there are within each group. And then finally, let's see, because because these are now species group, we have to summarize basically at the kind of plot level and species group level, because you can have multiple, like if you have multiple pine species or multiple oak species in a plot, it's going to have multiple records, and we want to just have one. So this is what the rich region species 2 is. It's just like kind of condensing that back so you only have one species group per plot versus you know multiple would be showing if you had 2 oak species. And then finally, the regen wide is to prepare it for the shapefile. So it's just like taking the species group and pivoting so that you have the columns of the species group and the rows of the plots. So like it's kind of a lot, but I think you can do it. And again, I feel like this is the most advanced way to do it. And once it's there, like in some ways it's making a lot of the decisions for you, so which is helpful. But if you do this more manually, that's okay, because up until I programmed this, that's kind of how Camilla and I did it. So there's no shame.
Yeah, and it's not a bad idea, like at the beginning, to like just take a look at your data set, see what you've got, and then make sure it's making sense as you move through it. And you might find, we haven't looked at the composition for all the parks, so like if you find out that like you've got like a rather large percentage of your regen is in like other native, you know, just the way it's working out, and like you've got a whole lot of stuff in there that's hidden, and like you might want to, you know, tweak it so that you pull out some of those species, or maybe there's some, I don't know, some species of concern. Maybe like you have a lot of, probably not, but a lot of Robinia pseudoacacia like got shoved in there, and maybe that's something that we want to like, even if you don't have a ton of it, maybe that's something that we want to pull out separately for the research manager. Anyway, there's a lot of considerations that like you do want to look at your data while this is doing it, not let it like make all the decisions like blindly, I guess.
Yeah, that's a good point. And there was also, I was thinking Ailanthus possibly would be one where you'd want to pull it out. Right now, the way this code is working is it's lumping all exotic trees together, but there didn't seem like there was really that much in Richmond that it was worth, you know, giving Ailanthus its own, but that might be one. Especially if that's the only exotic tree you have, then let it be Ailanthus, not other exotic.
Yeah, that's a good point. And that will, well, I don't know. There's also a lot of Norway maple around, so that might be your 2 exotic species, you know. But we'll find out. Very exciting.
Yeah, right. It's all been exciting to see what you guys find out, and whenever I'm like stressed out and having a rough day, I just like look at your guys' maps and like, oh, look at all the things we're doing. Because I've been really busy lately. But this is the stuff I'm really excited to see, because like we haven't done anything at all really with the composition data. We've kind of like done like network level summaries of some of the stuff you're doing. So like we know which parks have low or high stocking index, but like, yeah, this is where it's like, I think I'm on the edge of my seat. Even though like, I know it's going to be a while before we actually see the results. Okay, were there any questions, or should I try to code this?
I have a quick question. So as long as you're like the table that we made earlier, as long as it's like 12 or under species, you don't have to like play around much with the other groupings.
Yeah, right. And as long as the 12 that this came up with makes sense. And so at the very end of this code, there's the table rich regen species group. That is where it's going to show you kind of how they're distributed across. And so if you find that you've got like 6 genus groups that have like 2 or 3 records, and then your other native has like 100, then you're going to want to, you know, figure out the difference. And maybe it's that Betula should be on its own, or Acer should be its, or, you know, like that's where you're going to have to check it. And it may take a couple iterations.
Mm-hmm. Yeah, and some of your genus level ones, like Ulmus, might fit better in other native. you might downgrade, lump that one and pull something else out.
Yeah, Prunus. Is that possibly another genus? It didn't seem like it made sense for Richmond, but there's Prunus in other parks. But
Yep.
Prunus avium is exotic, so making sure that you don't lump native and exotic Prunus.
Yeah. Prunus. I mean, most of the tree Prunus is going to be Prunus seratna. I don't know if we have many other ones, but well, no, but in the regeneration layer, we'll have other species. That's true. Yeah, and you might find that your low canopy, actually, I'm pretty sure that for some of them, the low canopy group is going to be huge. And that'll be interesting. But I think for that is sort of the message that we want. If we pull out, say, Cercis canadensis, be like, wow, yeah, well, that's like nice, but like you can't have a canopy made up of Cercis canadensis. And so I think just lumping them into a, good for diversity, but not good for diversity and forest structure, but on its own group, I think it's fine. But we're going to see a lot of that.
Yeah, and I think the one species, and tell me if you don't think so, Camilla, that we may end up pulling out of the low canopy would be Ilex opaca. So we're it is a low canopy species. It's one of the bigger low canopy species, I guess, and it can be pretty common. Yeah, and we do have tree examples of it, whereas like the others, like you don't get Cercis over 10 centimeters really at all, do you? Or if you do, it's like barely.
Not in the forest. I've seen some really amazing specimens in people's yards, like chonkers. But no, I'm like, wow, that's a Cercis. But yeah, not in the forest.
Okay.
Yeah. No, Ilex is more of like a definitely gets up pretty tall, and it is a major component on the coastal plain. And it's resistant or resilient, I guess, to deer browse, and so it's been doing. They definitely get whacked, the new growth, but once the leaves get tough, I think the deer avoid it. So there's a lot of Ilex region when there's nothing else.
Yeah, and so I think all this is to say, like, we want Camilla to sign off on the groupings because I think she knows what the meaningful groupings are based on her experience in the parks. This is to kind of help you get close, but then, yeah, I think it's going to be helpful. And then we also kind of want to coordinate the tree species list and the regen. It doesn't have to be identical, but if there's a major component of something in the region that we're leaving on its own, we probably want to leave that in the map too, even if there's not a lot of it for the trees, just so you can see like, oh, look, there's a ton of Ilex opaca, or there's a ton of ash, say, in the understory, but not a ton of ash in the canopy. So we may want to coordinate that a little bit.
Yeah, you might want to do both of these before making too much headway in like the final stages, because you might want to tweak. Yeah, like so there might be parks that have like no Quercus regeneration, but Quercus is a large part of their canopy. We're still going to want to have Quercus as its own group in regen, even though normally you would have, like if you have one seedling, you would have grouped that into other native, but we'll want to have that out, to highlight the fact that there's none of it. If that makes sense. So yeah, you'll probably have to go back and forth.
Okay. I think I'll give that tip when I'm doing the code. Should I do the code now, or?
Okay. I do have a quick question.
Yeah,
sorry, just about the table. The table, then reg species. Is that just an account of like, or a tally of every time the species is mentioned in the original? Okay, cool.
Yep, it's exactly that. It's like doing count A formula in Excel by group. Yeah, and I'll show it in action so you can see what it does. But I tend to use this table a lot. And if you put as data frame in front of table, then it becomes a data frame, and then you can write it to CSV if you want. So that would be a way to kind of write this into a CSV and then have it in Excel. if you want to look at it. Okay, so I think I'm gonna, unless there's anything else, I'm gonna share my screen. And also, please don't ever apologize for asking a question. Like, just like don't apologize in general. You're awesome people. You do great things. Sorry, I recently read an article about how like women apologize like 10 times for every time a man apologizes. And so I'm just like, duh, and I apologize all the time too, but like I'm trying to stop. So like, don't apologize for being amazing. Okay, all right, I'm gonna share my screen now. Can you see my R code? Hopefully soon.
It's there.
All right. So I'm just gonna kind of start from scratch, and
It does look like you have a bit of a lag.
okay.
Just so you
Then
know.
I will try to talk slowly. I'm just gonna load the library. Load the data. Does this work? Sorry, I need to see what I'm not in the project that I normally use. Oh no, that's there. Oh. Okay, there we go. I loaded the data. So let me start at the top of the code. Tidyverse and our Google. Well, all right, I'm ready to get started. So I'm just doing that first code chunk that we always seem to do, where it's the join function. And here we care about all species, native and exotic, and then also all canopy forms, because we're looking at the composition. So that's why those are coded differently than what we've done in the past. And I'll show you what the table function does. I'm on that now. Oops. So the table that I just made, this was based on the Latin name. So it takes every unique value of Latin name and it counts up the number of rows that it occurs in. So that's where ilex opaca comes out as being like in 30 plots, basically. And then there are 27 with no species recorded. We'll deal with no species recorded later. And then we see like Acer rubrum, liquidambar, those are big ones. Carpinus, which is a low canopy species. Quercus red group, Liriodendron. So that's where we come, that's kind of the first step to see like what kind of pairings we think we might want to do. And we see, like down at the bottom, there really aren't, there are quite a few species that are like Betula, there's one Betula or there's one Cornus florida. And so that's where these kind of stragglers down here will probably be lumped into a bigger group, either low canopy or other native, or their genus. Okay, so that's kind of the first cut to see what's the most abundant. And then I'm just gonna make species code. The way that functions work is you give them arguments. So df is, you can put whatever words you want in here and then you call on them later. So for this function, I'm saying you're going to have to give it a data set. So df is the data frame. You're going to have to give it a data frame. But that's all you really need to give it, and it's going to do the rest because I'm giving it basically similar data sets and I know what's going to be in there. So as long as like Latin name is one of the columns in the data set, all of this will run. So within this function, I'm taking my data frame and I'm creating a genus and this word function we'll just take the first words. It's basically any text before oh, can you guys see my window? Shoot, I just got like a weird, like, which window are you sharing? Hold on.
Oh,
I think
no,
I might
we
have screwed up.
could see it.
Oh, you can you
well,
now?
No, now we can't, but we could.
Okay, let me, okay, let me try this again. Sorry. Teams is so confusing sometimes.
They're actively sabotaging, you know.
Yeah, oh, that's the wrong one. Sorry. No, that's not the right, why? It's like not showing the screen that I normally share suddenly. Okay, here we go. I think I got it. Do you see my R screen again?
Not still waiting.
Okay.
Could be loading. Yes.
Okay. And so just so I don't accidentally do that again, if you have, it's hard for me to actually see chat. So either Camilla, if you can monitor chat, or just like speak up, that's fine too. You can interrupt.
Yeah. No, I don't know. I guess that was just Teams telling you incorrect information.
Okay. Thanks, Teams.
Yeah.
Okay. So back to this function, so functions they're kind of advanced programming, but once you figure them out, they can really speed up your workflow, and I really like doing them sometimes. And I kind of think of them as like formulas in Excel in a way. Like if it's something that you would want to calculate in a formula in Excel, you can probably figure out how to make it a function in R. But so what I'm doing, the word function, that's where I was. Basically, any text before a space, it's going to take that as a word. And so Latin name 1 is going to be the first word before the space. That's genus, usually. Species, we have some species like Quercus on its own, or Carya on its own is the Latin name. And so if there's no second word to make a species, I'm putting SPP. If there is a second word, take the second word. That's what this if else says. So if the second word doesn't exist, is an A in Latin name, make it SPP. Otherwise, make it the second word in the Latin name, which is the species. That's where I'm getting species from. And then I'm using those two to come up with the species code. So the species code is a couple of things are happening here, but 2 upper makes everything uppercase or capital. So that's helpful. And then I am pasting the first 3 letters of the genus. That's what substring does. Substring takes a text field, and so you tell it the text field, which here's genus, and then I say take the first through the 3rd letters. So it's 1, 2, and 3. If you wanted the 4th, you'd say 1 through 4. And then it's also pasting the substring for species, which is 1 and through 3 together. And when you do paste 0, it's not putting a space between any of the things that you're pasting together. If you do just paste without the 0, it'll put a space between them, or you can have you can specify what you want to separate it by. But paste 0 is just going to put them all together and create a species code that's 6 letters. And it's creating a new data frame out of it called DF2. And then DF2, for those quirky ones that I wanted to make sure we didn't have duplicates, I put Acer Sac2 for, if the species is Saccharinum, basically Acer Saccharinum, then make the species code actually ASAC2. And then because we have Quercus red group, and the red has a parenthesis in front of it, and parentheses are kind of weird within strings, I just cleaned it up. And so it's always going to do that correctly. And then at the end, it says return data frame 2. So that's the output. You're going to be returned with the data frame as an output with a new column, with 3 new columns, probably genus, species, and species code. So that's just something that I wanted to run. And then when you make a function, it actually shows up in your global environment, so you can use it. So like it's, you know, giving me the option to use it. Whoops. And once you start building functions, and if you get a lot of them going, you might actually think about building a package. So functions are kind of the building blocks of a package. Okay. Now that I have my make species code function, it's just really easy. So first I'm going to show you what the data set looks like before I run the function. So we have our Latin name, common name, all that stuff. This is all the region data you're used to looking at. But now when I wrap make species code around the data set, it now has the genus, species, and species code in there. So you can see at the bottom, there's species code. Okay. So now I'm going to make the species list function again. Just to save myself time. And this is just taking the species code column that we just made in the data set, and giving us all the unique examples of it. So unique, if you give it a huge data set, unique allows you to come up with like what the different, like if you want all the species, you come up with the unique species in the list. It'll do it for you. So just making the low canopy list first. So I'm on another chunk, if that makes sense. I'm on the 4th chunk that starts with make species list. Where's... Oh my gosh, I'm sorry. My hands are like on the wrong keys on my keyboard. I'm like typing everything wrong. All right, so here we're gonna filter on this. There's a canopy exclusion field in the data right here, actually. You can see it. So that's how we tell low canopy. And we also don't want no species recorded. Then we're just going to use the make species list function. Run it. And so that's what it did. So it came up with, it filtered the Richmond data on canopy exclusion species equals true. And then this make species list is just going to select only the species code out of that full data set and then return the unique values out of that. And that's what we have below. Do the same for exotic species. And there aren't any. So if it returns 0 length, it means that there weren't any. I'm going to do it for the rest of these. So I got Caria. So we have Spa, Tomentosa, and Glabra. It's just Spa and Americana for Fraxinus. Just Tata, really. Let's see how many oaks we got.
Kate, you're lagging, at least on my screen a little bit. Could you just wait up a second?
Sure. So I basically ran through that whole code chunk that started to make species list. So I'm creating my species, like genus lists, basically.
Okay. Yeah, then you don't need to wait. It's fine. It'll catch up.
Okay, I'm just like filling space with words while things catch up. So I'm just going to kind of scroll back through my console a little bit. These are all the species that we've given a group. So we have our low canopy species, we got Archaria, we got Fraxinus, we got Pinus, Quercus has quite a bit. And so the next thing is to group all of these so that we can use it as a group to filter against. So our bind is just binding rows together.
I think you might be frozen, Kate. I don't know. Are you moving? Is it moving for anybody?
No.
Shoot.
Oh, wait.
Do you
Wait a
see
second.
grouped underscore species?
It just updated for me. Oh, and your cursor blinked once. Try. I don't know. Is everyone caught up now?
I can stop sharing my screen and start again, maybe?
I think it might be working now.
Oh, okay, good.
Yes. Yes, you look. Yeah, your cursor is mobile.
Okay. Great. So this R bind, you're just binding rows together. So it's basically like taking each one of those species groups and putting them together in one long column. So if I print that, see these are all species that have been assigned somewhere to a group. Do you see in my console? It's like 30 species or so.
Yes.
20 species or so. Okay. So the reason I did that is so that I could make an other native group that doesn't include any of those species. Okay, so I'm on the chunk that starts with group species, and then now I have total number of plots. To calculate for the percent of plots that something occurs in, just because I mean, you can hand do this, like if it occurs in less than 5 plots or less than 10 plots, you can tweak these numbers. I just did it on percentage because it seemed like it required less thinking. All right, so I'm on the other native chunk. So I have Richmond data. I'm grouping by species code, and I'm going to mutate the number of plots. So I'm going to break this up into multiple steps so you can see what's happening. So first, let's look at the data again. This is our region data. So what I'm going to do in this next step is take the species code column and group by it and basically count the number of the percentage of plots that each species occurs in. So it's basically out of 32 because there's 32 plots in Richmond. So if I run this, what did that do? Oh, now it's a tibble, so it's not showing me everything. Stupid tibbles. I'm just viewing the data now. If I scroll all the way to the right, basically all I did in that line of code is some sorting by species code right here. Can you see the data set right now, hopefully?
Yes.
Yep.
Okay, so my mutate, I group by species code and I calculated the percentage of plots that a species occurs in. So you notice that species code, this is all Acer rubrum, and they all have the same number. That's what the group by and the mutate did for me. Instead of like group by summarize would have ended in, there'd be one Acer rubrum record and it would say 81.25. And then there would be one Amelanchier SPA and it would say 9.375. So this is just a way to kind of like calculate a number based on the data, but keeping all the rest of the data the same and having the same number of rows that you started with and just creating a new column. Did that make sense?
That actually helps a whole lot. I was wondering,
Okay.
with all the summarization, summary functions, it was just kind of confusing, but I get it now.
Okay. And also, if you notice down here in the console where it's got the tibble listed, when I do like head other nat, it sees it as a group data set because I didn't ungroup it yet. So it says groups, species code 6. And so if this wasn't a group data set, this line wouldn't be here, the groups line. And that's why I ended up, like, because it's a tibble and tidyverse is like kind of, it sees it as a group data set. It's going to continue to treat it as a group data set and cause problems. And so that's why I ended up ungrouping it. If you don't run into problems, you don't have to ungroup. I'm just going to go back to the code now. So so there's my ungroup. And then now for this other nat species group, I'm now saying, okay, everything that's already been grouped, we already found that grouped species list. Everything that's already in that group, don't use it. So only filter species not on this list. I also don't want anything exotic. And I don't want anything that's in more than 30 plot, or at least 30% of the plots. And then we're using that same make species list column or function that we did before that will just give you a list of species that are unique to that group. So if I run the whole thing, and my other native are now Prunus, Seratna, Nyssa, Dioscorea, Robinia, Juniperus, Betula, Morris, and Celtis. Oh yeah, Celtis occidentalis. So those are species that haven't been found in more than 30% of the plots and don't already have a group and are native. So that's how we come up with our other native group. All right. So now that this was like going through this, these were the groups that I thought would work the best based on that table function of the Richmond data to find out the most abundant species. And so now I'm going to do the case when to assign the different species to species groups. And then I'm going to check whether I ended up with 12 or less. So here, move this over. So we have our taking our Richmond data set, and we're creating a new column called species group. And so now, again, we still have that species code in the data set. So if the species code is in the low canopy species group, paste low canopy into species group. If the species code is in the exotic species group, paste exo species into that new column. So it's just going through anything that doesn't fall into any of these groups is going to get its species code pasted as its species group. And that sounded very confusing as I was saying it. Did it make sense?
Made sense to me. I don't know.
Okay. It's like, how many times can I say species in a sentence? All right. And the last thing is, because we're doing all regeneration, like all stems, you'll just want to create another column that's regen density if it's not already in there. And then it's just seedling density plus sapling density. But it might actually already be in there. Let me check. Now that I think about it, it's not already in there. Okay. So yeah, you just need to create it. So again, this is just mutating, so I'm just creating 2 new fields at this point. So, we created the species group. Now you can see down below my console, there's species group, and it's Locan, Amelanchier is getting Locan, Acer rubens on its own, Carpinus caroliniana is in the low canopy, no species has its own group, Ilex opaca is in low canopy, Fraxinus is in Fraxinus, so you can see that, and then the regen density is total that you want. Okay, we're almost there. So now we run the table function. See how many groups we ended up with. So we have we have 12 groups. That's great. And in our other native, like 38 rows. This isn't perfect because I haven't actually summarized yet. So like, there are only 32 plots in Richmond. So you would think like, oh, the number can't be over 32. But what this means is that there are multiple other native species on a certain plot. And so it's counting more, and like low canopy. So you often can have like Carpinus and Ilex opaca in the same plot. And so that's why it's showing up more than 32. But this does just give you a good idea of distribution. So we don't have any like glaring, other native is less than like oak by its own or low canopy. So I think it's all right. And the species on their own seem to make sense too, like Acer rubrum, there's quite a bit of that. Liriodendron, liquidambar. So I feel pretty good about those groups, but this is where if you end up with more than 12, you may need to go back and kind of rejigger this so that it works. If you end up with like only 4, you also may want to rethink about it and say, if you end up with 4 and one of your groups is like oak, maybe you split out the most common oak and let it be its own species. I really don't know what this is going to look like for some of the parks. Camilla probably has a better idea, but this is just something that's going to be iterative.
I have a quick question, if that's okay.
Yeah, please.
Okay, I might just be confused on this, but if you have something that's like a low canopy species and is also an exotic species, it's only supposed to be counted once in like one of those categories, right?
Correct. Okay. Yep. And so it would be exotic trumps everything. So if it's exotic, you want to put it in the exotic group. And so I'm glad that you mentioned it. So I should also have in the low canopy code, I should put n exotic equals false. So we can make sure that a species doesn't get counted twice. There were no exotic species in Richmond, so I didn't notice it. But yeah, I'm glad that you actually mentioned that. So let's change that code. I will change it right now. And I should say, like, filtering, you can have like multiple things together. Like you can filter multiple things together. But once it gets more than 2, I generally just break them up just to make sure it's filtering correctly. So I'm going to break it up here. This is where I need to add exotic. Okay, so that's the better way to do it. I need to make sure I update my code. All right. Yeah, thank you for catching that, Kella. Any other questions, or did that make sense why we just did that?
Makes sense.
Okay. All right. So let's just view the data for a second. One thing, I don't know if you've discovered this, but I find it to be really helpful, is if you click on this show in new window, it actually gives you a separate window. So you can look at the data bigger and like move it around so you can see your code behind. I don't know if you can see what I'm doing, but it feels more like opening it in Excel where you can actually view it instead of it being kind of within your RStudio. You can also filter. So let's see, I'm going to filter on like, oops, that didn't help. I just want to see like all plot 15, just to kind of see what's going on here. And so in plot 15 in Richmond, we have like Carpinus, Caroliniana, and sassafras are both low canopy species, and and Ilex opaca. So when I look over at the very right at the species group, I have 3 versions of low canopy here. So what I need to do is summarize so that I only have 1 low canopy for plot 15. That's what the second group by summarize is for. So I'm grouping by the original data set by plot name, plot number, x coordinate, and y coordinate, because those are the things I need for the shapefile. And then what I really care about is grouping by species group. It's really what we really care about is grouping by the plot number and the species group, but we're carrying all of this along so we don't have to add it later for the shapefile. And then just summarizing regeneration density and summit. So if I do the table for this one, I shouldn't have anything over 32. And that worked. So so now there's no more, every plot species combination is unique. And so there's no more than 32 low canopy because there's no more than 32 plots. Hopefully that made sense. And then let's just data again. So this is all we have here. There's plot name, plot number, x coordinate, y coordinate, species group, and region density, because that's what we did in this summarize bit. Now we want to spread it or pivot wide so that the species group column is now every one of those species is its own column. And also, if you notice, there's a no species in here. So these are plots that had no species recorded. And for those, we're just going to remove them from the data set. So there are a couple of steps in here that we're doing. So we're taking this rich regen species 2 data set. We're selecting, I probably don't even need to have that in there, basically all the columns we care about. I am sorting by species group so that the columns are sorted alphabetically. And then the pivot wider is taking the names from species group. Those are going to be the new names of the columns. Taking the values from regen den. Those are going to be the values inside the cells. And then I'm filling any values with 0. So if there's a species that's not found in a plot, it's not going to come in as NA, it's going to come in as 0, because it just means that we didn't find it there. And then I'm removing the column that's no species. So the result is a row for every plot and a column for every species. And just to make sure that it worked, let me also maybe ungroup. I don't think I needed to do that to make the code work, but I think it's behaving better. The Tibble up before has the groups still, which sometimes can cause problems, whereas now after taking the groups off, it just looks like a normal data frame. Oh wait, there we go. So now I just want to make sure there are still 32 plots. Phew, okay. So there we go. So that's the data we want, and now we just need to make it a shapefile. Doing the thing, they're the same 3 lines of code I think you're all getting used to running. So it's just coordinates are there, proj4 string, and then you write the data, or write the shapefile. Any questions?
I have
Can
a
you-
question. Oh,
Okay.
You can go.
okay, thanks. Is it okay if like one of my species columns, all the rows are 0 for all of the plots when looking at the final like regen wide table?
If that happens, you probably just don't want to have that species included on its own.
Okay, cool.
Yeah, because it's not going to show up as anything in when you're plotting it, because it does. If it's all zeros, there's no data to plot. So it could either be that something went wrong, and it should be there. I mean, you should be able to tell that from the first table, the species DF. If there's if there's a non-zero number in there, but like your end result returns all zeros, maybe something went wrong. But if it's correct and it's all 0, then it's kind of like a species group taking up space that you don't need.
Okay, cool. Thanks.
What else?
My question was just, are you going to be adding in the exotic filter thing and the ungroup in the end of the pivot wider into the training code?
I will. Yeah, I
Okay,
can do
thank
it
you.
right now. Hold on. So let's see. I was here. I will redo that. Get to see a little picture into how I'm maintaining all of this. I'm just gonna knit that so it goes through. Takes a minute. Once it's finished, I'll actually show you how I do the GitHub thing, just so you see it, but we'll actually talk about it more formally at some point. But I have a GitHub repo for everything. And so it should show up now as having exotic equals false. Yeah, okay. So that's good. I'm just going to commit this to GitHub before I forget, so it goes live for you guys quickly. So here's the awesome thing about GitHub. So it knows what the data set, what the code was originally. So it's showing the differences here. So it's red. And then it's showing what changed. So you can see this is the, where I broke up the filters and then have the exotic equals false. So it lets me kind of review it before I commit it. And then I'm just saying what my commit is, like basically what I did. And then I'm going to push it to GitHub. And within about 5 minutes, the website should be updated. So the commit just kind of like stages it and says like this change is like ready to go into GitHub, and then pushes it to GitHub, pulls things down from GitHub. And if I show you my GitHub repo for all of this, it should say like updated 30 seconds ago. And that's the commit that I did. Added exofilter to low canopy. And then the website is over here. It can take like 5 or 10 minutes to update, but it should be updated soon. That's the beauty of GitHub.
That's so awesome.
Yeah, it is. Yeah, so GitHub is super helpful in a lot of ways. It just like making the connection between RStudio and GitHub can be tricky. And then making sure that like it's actually talking, like the repository that I have on GitHub for all of this is talking correctly to the project that I have in RStudio. So like it comes with extra effort that I'm not sure it's worth us using right now as a group, but it could be useful in that way if we get comfortable and decide we want to do it. But for now, I think I just kind of showed it and how amazing it is, but we probably won't use it in our workflow too much. Except I will, let me just show you something that I like about it as well. There's this issues part. You guys can actually, I think you can report issues. So if you find something in my code that that you're like, oh, I think that either you know, you need to fix it for my park, or can you change whatever, you can actually file an issue. So it's just like, this is the normal repo and there's an issue tab. So you go to issues and like you can actually like make an issue. So and then like I will see that's an issue, and when I do my commit, I can actually say that I closed it. And so it's a way of like tracking things that you did, like tracking your workflow. So like in this commit, I would have been like added exo filter to Locan, fixed issue number 1, because that would be the first issue, and then it closes that issue, and so it'll show it as a closed issue. So for like people working on big projects, if you know you have a bunch of issues that you want to fix, and issues aren't necessarily bugs, it's a nice way of tracking whether something's been fixed or not. And it always has like the history log of everything that you've done and everything you fixed. So it's pretty nice. Okay, back to our code. We got our shapefile, yeah. So that's for the regen data.
I was wondering if you could pull up the regen wide table, because I'm just looking at it and it looks like only one of the plots has Pinus. But I'm assuming because it has so much Pinus and it's a really important species to report on.
Yeah, and it, yeah, I think there was more Pinus tree in the canopy, and that's why I ended up putting Pinus on its own.
That makes sense. Just wanted to make sure we're getting the same result, since I'm also working on.
Oh, this is right. This is your part. Yeah, you're right. There is only one. But let's see if the tree comes up with having more. Because right, the mismatch is where we're also interested in being able to show. But yeah, good point. Okay. Okay, anything else before I get into tree composition?
Maybe we should take a short break.
Good thinking. I need more coffee.
I
Okay.
need to go to the bathroom.
All right. So 5 minutes, or you know, take whatever time you need, and then we'll check back in and get started. just waiting for Camilla to come back on so I can get started. Okay. All right. Did any questions come up before I get started, or should I go with the tree comp? Okay. And if this doesn't completely make sense, I think once you start working with your data and actually looking at what the output is doing, I think it'll start to make a lot more sense, kind of what I'm doing. And I think something that I maybe should have said at the beginning is if you want to do this somewhat by hand in Excel, that first line that's, you know, the rich regen species data, the first line that you run, you can write that to a CSV and then open in Excel if you want to do that, and that's okay. All right, so now I'm gonna share my screen for the tree stuff. Or wait, hold on. Did I already go through the tree metric on the website? Okay, I'm sorry, what's wrong with me? Maybe I should do that first and then share a screen. So, so everyone had that pulled up.
Yay. Cat.
Oh goodness, it's like a puma walking across or something. Okay. Actually,
I thought Camilla was just really excited about the art trading page. I like couldn't see what was going on.
Yes, I was very excited about that. It's not fuzzy, but it's still very cool.
And if you notice that the website has updated what we just changed, so the low canopy species now filters on exotic, I need to add that for the trees as well. All right, so let's go to metric 11 now, tree composition. It's a lot of the same steps that we just took in regen, but doing it with tree data. And you guys haven't worked with the tree data yet, as far as I know. So there's a join tree data function, and it has pretty much the same arguments that you have for the regen data, except now we only care about live trees. We're not interested in mapping the composition of dead trees right now. So it's all species, all canopy forms, but then only live species. That's what status equals live is for. And then I kind of realized as I was going through this that the join tree data function doesn't return that canopy exclusion column that we need to check out low canopy. It's because like there aren't a lot of low canopy species that make it to the tree size, and it didn't come out as being important yet, but I actually needed to add that to the function. But for now, we're just merging the plants table to get that column. So that's what rich tree 2 is for. We're just merging the Richmond tree data, and then just for the plants column, or the plants table, just the column TSN, which we're going to link by, and then canopy exclusion. So it's not bringing in everything in the plants table. And then the next line, the make species code, again, that's that same function we used before, where it's just taking the Latin name column in the data set and making a new column for genus, a new column for species, and then a new column that pastes them together in 6-letter code. And then I wasn't sure if you guys were going to be doing this all at the same time. I think it kind of makes sense to be doing it kind of together because we want to coordinate tree and regen, but if you don't, this make species list function. I put it here again if it wasn't already in your global environment. The make species code is another one of those that you'll need to make sure still like you've run it since you started R to actually work. And if you try to run it and it says it can't find species code, it just means, or make species code, it just means that you don't have that function in your working environment yet. Okay, but all of this is the same that we did before. So we're coming up with like the low canopy, the exotic, and then the genus lists, the other native list, and then creating that species group. This is all the same stuff that we just did. Summarizing so that you have the number, or we're doing basal area is the column that we're using to summarize by instead of like density this time. You could also use like number of stems, but I think basal area makes more sense. So that's what we're doing. It's dividing by 400 so that you get basal area in meters squared per hectare, just so you know, because our plot's of 400 square meters, and that's how you do the unit conversion. And then we do the tree wide so that we have a column for every species group and then a row for every plot, and then we make the shapefile. So it really is like the same thing that we just did, it's just with the tree data. Any questions before I code it? Nope. All right, then I'm gonna share my screen and try to code it. All right, does everybody see my screen now?
Yep.
Okay. I was just talking for like 30 seconds on mute and they're like, why is nobody responding? I'm really sharp. I was totally muted, and you can't see me that I'm talking and muted because I turned off my screen, so my screen is faster. But anyway, what I just did is, you know, I fixed the filter for low canopy on trees too, and then I added that ungroup to the pivot wider, so that it's gonna once I commit that to GitHub, it'll update the web page. Starting out, let's do. Gonna make a little break there. All right, starting out, Richmond tree equals join tree data. And if you, like I often forget, is it supposed to be live or is it supposed to be alive? And again, you can always check by going to the help. And down here, status is either all, live, or dead. And then like species type is either all, native, or exotic. I haven't added the Robinia exo thing in here, Camilla, yet. Yeah, that's all the things. Okay. So next step is to pull in the canopy exclusion column, because if you look at the actual tree data that's returned from the join tree data function, it's just Latin, common, and exotic. I don't have the other data kind of composition in here.
Hey, I'm just curious why you would keep like the full data set when at the end you just pare it down anyway. Like, is there a reason why you don't filter out the columns that you don't need in the beginning?
You can do that if, especially if you're working with huge data sets and it's slowing your machine down, you want to pare down your data set as much as you, you know, just to what you need. Yeah, you can do that. It's just, it's an extra step that I know that through the process, it's going to whittle it down to just the columns that I care about. But yeah, you could start out with that if you wanted.
Okay, cool. Thanks. I was just curious.
a grad student that's in the same lab that I was in for my PhD is working with FIA data, and she's hitting limits. And so she just emailed me yesterday and asked me kind of a similar question of like, how do you work with huge data? Like, what tips do you have? And that was one of them exactly, is like, only work with the data that you need and don't, carry along a bunch of stuff that you don't. So make your data set small from the beginning. Okay, so I'm going to merge. This merge is kind of what you suggested, Katie, but just for the plants table. Really just, I'm merging two data sets, but I'm just merging two columns from the plants table, the TSN, which is like a unique identifier for every species, taxonomic species number, and then whether it's canopy exclusion or not.
So the point of that line is essentially just to add the canopy exclusion data to the data set, because
Yep.
TSN, okay, cool. I was confused about that yesterday.
Yeah, so if we just look at this now, it's the same data set as rich tree, but now it has this canopy exclusion column. That's all it did.
What does all.x and all.y do?
That's whether it's going to be a left or a right or a full join.
Oh,
So
okay.
all x equals true says take in all of the Richmond tree data, even if there's like a species that doesn't match the plant table. That shouldn't happen. If that happens, let us know, because it means there's a problem in our data. But yeah, it's saying take everything from the left table, which is rich tree, but don't take everything from the right table, which is the plants table, so that species that don't occur in Richmond aren't carried into this merge. If you said all y equals true, it's going to also, have every species in the plants table merged into it, and we don't care about that. So yeah, that's why I did that. This is X and Y. All right, so now we're going to make the species code. Again, if we look at the head now, it's the same one data set we just looked at, but now it's got a genus column, a species column, and a species code. And the reason that I'm still kind of, the genus and the species code seem like you're not going to use them again, they're not useful, but it's possible that if you're grouping, if you have to kind of like rework it a couple of times, I found that it was useful to still kind of carry these along, the genus and the species, instead of like getting rid of them and just resulting in the species code. So it's carrying over columns that you may need, you may not. I don't think it's hurting anything leaving them there for now. Gotta make species list. All right, so now we're gonna do our low canopy tree species list. I think we only have a couple of plots where there are no actual trees. So the filter Latin name is not equal to no species recorded, probably is extraneous here, but we did it for the regen just to do the same process. And also don't want exotic species on this list. Then we are going to make that into a species list. That, and we see that tree-wise, the low canopy species are Magnolia virginiana, sassafras, carpinus, Cornish florida, and Ilex opaca. So that's our low canopy tree species list. And Just going to go through and do all those other, the genus level groups that we had. Again, there's no exotic trees in Richmond. Area, Fraxinus, Pinus, Quercus, Ulmus, making our grouped list. I should point out, so in this is line 144 on my in my R script, the grouped underscore trees. I only bound groups that actually have data in them. So notice the exotic underscore tree group is not in here. So it's where you want to check if you're returning empty lists and don't include them on here. But if there was an exotic tree on the list, then I would need to include it here. Number of plots, which we know is 30 again, 32. Making our other native group. Our other native group has a lot of the similar species as before, but now we also have sycamore and walnut. So that's cool. And we got we're going to use all of those to do that big case when to assign our species group for trees. So again, it's like low canopy, exotic, and then all the others. Actually going to do the summarize first and then do the table. So again, if there are multiple like species within a group on a plot, there are going to be multiple rows of a species group on a plot. We want just one for the pivot. So that's what this tree 3, rich tree 3 is for. So now I'm going to look at how many groups I have. So there are 12. I ended up with 12. And Pinus, now there are 9 plots with Pinus. And so that's kind of why I decided that I would keep it. If there was only one Pinus, maybe I would think about not having Pinus as its own group and maybe splitting out, taking another native species and letting that be on its own. And I guess I forgot to do the table up here to find out what the most abundant species were. But we can do that. Species code. Oh, and let's see. Acer rubrum seems to be pretty. Oh, liquid ambar. There are a lot of liquid ambar trees in here. So I forgot to do this kind of first cut like I did with the regen data to kind of see what the most abundant species were. But yeah. So there's a lot of trees of loblolly pine, Pinus taeta, but it's probably only on a couple of plots. That's why it shows up as only like 9 in that table below. There are 9 examples of it, but there are actually 86 trees. And so let's do our pivot wider and then look at it to see if it makes sense. And also I ended up the species group, there are only 12. So I'm happy with that. Oops. Now we're doing our pivot wider, where this time it's basal area, that's the values, and values fill 0. So this is what our data set looks like. So we've got 32 plots, and these are all the species across. And so now, yeah, there are 9 plots that have Pinus now, and some plots have quite a bit. And so like in Richmond 133, it looks like Pinus is the most abundant tree species basal area wise. So that's why I liked kind of keeping it on its own. So then the last part of that is just writing it to a shapefile. And then you plot it. Any questions?
Could you just like talk through how you got the table to summarize so it only shows up to the number of plots you have? If that
Yeah.
question makes sense.
Yep. Yeah.
Okay.
So starting up at the top, this first tree one, every row is a tree within a plot. And so, if there are 12 acerubrums, there are 12 acerubrum rows for a plot because there are 12 acerubrum trees. And so when you do the table species code, it's counting up basically all of the trees by species code, which is useful. It's useful to see that like there are 130 liquid ambar trees in Richmond in the last 4 years, but it's possible that it's only on like one plot. And so if it's only on one plot, then, if you have a lot of groups and you're trying to whittle it down, even if it's super abundant, you may end up kicking it out of its own group into like another native. So I think this first table, when you're just looking at the tree data, it's useful to see what the most abundant species are. But then as a check to see if you have good plot distribution, you need to go further down. So we are doing our coming up with our species groups, summarizing the species groups by species group within each plot, so that we have no more than one species group represented within each plot. And the value that we care about is the basal area of that species group in the plot. So that's what the summarize is. And so this is where we get the table of how many plots a species occurs in after we do the summarize.
Okay, thank you.
Did that answer your question?
Yeah, I was just a little confused, like what part of the code did it. So,
Oh, okay.
thanks.
Yeah, so it's towards the end. And I think what I did in the website was before I actually summarized at the plot level. So it has more. So now this is the number of trees in each group, not the number of plots represented. So before I do the summarize, when I'm up here, I'm still working with basically the original data. I've just added a bunch of columns to. And so when I do the table for that one, I can see that, for example, there's 130 liquid ambar, there's 111 quercus trees, and 30 other native. So it might be useful to actually do, look at both of these if you are trying to continue to pare down, because you might want to like balance kind of both of these. So how many trees there are of a species group, and then also how many plots they occur on. It might help you come up with a combination that works. And again, there's a lot of judgment involved here, but that's just how it goes. Any other questions?
I do have a minor question. I was wondering, in the pivot wider code snippet, why did you comment out the pipe to select for no species? I just noticed that.
Oh, yeah. It was because I copied it from the regen one.
Oh,
And
okay.
in the regen, there are no species. And so like that was coming out as a column. But we don't have any plots in Richmond that don't have any trees. And so
Gotcha.
it just didn't, it wasn't necessary. So yeah, I could just delete it.
Cool.
Yeah, but are there, Camilla, any plots that don't have any trees? Like, we have that one in Saratoga.
Well, there's a deer exclusion in Richmond with no trees, but
Okay.
we're not dealing with the deer exclusion, so no. Every plot has a tree so far. There is a plot in Hopewell Furnace that is getting very close, but
Okay.
so far still trees.
That doesn't sound like a fun plot. Is it a
No.
barberry plot?
Yes.
Ooh. Okay.
Yeah. Anyway, but so far so good.
Okay. Yeah, any other questions? All right. I am going to add a little bit to the actual code on the website and then commit it. You can see my GitHub workflow again if you want. This is just helpful because I know that I will forget to make the change if I don't do it right now. Okay. Do you guys need a break before we get into invasives, or are you happy to get going?
I'm okay right now.
Okay. All right. So invasives, we can start with invasives. I think after I do this, I'll stop sharing my screen. And then if you just pull back up your website. All right, everyone have the website up? Okay. It's not going to update in front of your own eyes. Like you have to like refresh for the things that we just changed to show up. But usually it takes a couple minutes. And this is so much better than having to like copy the HTML code onto Google Drive and then like you have to remember to download it. And yeah, now you just know that it's always like the most recent version. Okay, so for the invasive metrics, there are kind of two places where we're going to be summarizing the invasive data. One place is going to be the quadrat level. So we have another function that we're going to be using, which is the join quad data. The other is we're going to kind of come up with all the invasive species we found on a plot, and that's going to be in another place where it's like actually combining all the composition data we collect. So trees, regen, quadrats, everything, putting it together, and if an invasive was found in any of those, it's going to say that it's present. So it's going to be, I think, like the last metric that we're going to cover. So it's like taking from two different places. For the invasive cover by cycle, we collect that in the quadrats, and so we start oh, right. And so this is where it gets complicated too. So the plants table has an NETN invasive column. This is like true or false for NETN invasives. The Mid-Atlantic one has changed over time. The NETN one has always been the same because we always collect all species in our quadrats. Mid-Atlantic, we have that indicator list, and the indicator list has changed over time. And we want to make sure if we're plotting like trends over time that like invasive cover doesn't increase just because we suddenly added ligustrum. And so, you know, you get a bar is much higher because of that. So for this first metric, we're only going to be mapping, or it's going to be like the bars over time, like we did for seedling density. But we're only going to be summarizing these species that have been on the invasive list from the beginning, like the indicator list from the beginning. And in the Google Drive, in the Midden CSVs, there's a new invasive list.csv that you're going to need to download. And let me just make sure that it is in fact there. And so this is something that we already had to figure out for our invasive trend analysis for Mid-Atlantic. And so I just used that. Yeah, so just in the Midden _forest _CSVs, just on its own, there's invasive list.csv. So you're going to want to use that, and that's what we're going to kind of filter on instead of making these changes in the plants table, just because I don't think it's worth making the change right now. Okay, so what you're gonna do is you're gonna load the invasive list, and I think the invasive list has like multiple networks listed. This is like what we used for our invasive trend analysis. So this is just going to be pulling out midden, and then oh, and it has like years added. So we're going to use that in one of the tables later to kind of like let resource managers know like when species were added, so it's clear for the invasive table. So anyway, right now what we're doing is taking the invasive column for midden. As long as it's set to 1, that means it's been on the list forever. As long as the year added is 2007. Sorry, let me back up. So we're filtering on, it's on the main or midden invasive list, and it was added in 2007. So basically from the beginning, and then select the Latin name. So that's giving our list of invasive species that we're going to filter on for this metric. Okay. So the next code chunk is we're joining the quad data, and we're just pulling out exotic species. So when we're doing this, what we're going to get are all exotic species. So that includes like apples, you know, like Malus, which isn't really exotic, or sorry, isn't really invasive, but it's you know, European. And then it's also going to be pulling in species that we added later. So like wavy leaf basket grass is something that became a concern later, but we don't want that on this metrics list. So so that's why we need that invasive table. So basically we come in, we pull in the exotic species. It's whittling it down a little bit, but it's not kicking out all the species we want. So then the next line, the rich invasive species, is actually taking the exotic one we just made, but filtering and only taking species in that data set that are on the midden invasive list that we just created above. So that's how we're only pulling in invasive species that have been on the list from the beginning. And then the problem with this step is that if there are plots that don't have any of these species on it, it's going to kick that plot out too. And so we're going to have to like pull back in the plots that don't have any invasives later. So it's a little bit more complicated than what we've done up until now. Okay, so we just want like the total cover of all invasive species. We're not doing individual ones in this metric. So that's what the rich invasive species 2 is. It's grouping by event ID is the GUID that we're going to use for our table join. So that's why I'm keeping that here, the globally unique identifier. It's unique for every visit to a plot. The plot name, and then the cycle, and then we're summarizing average cover. So, you know, all the invasives on a plot are getting summed so that we get average cover total of invasives. And then, because again, there are plots in Richmond that don't have any, and I want to pull those back in so we can plot them. The way that I'm doing that is I'm creating a separate table that is the Richmond plot event. So it's like all the plots that have been sampled from 2007 and 2019 in Richmond. And then I'm doing a left merge. So I have all the plot data. And for this merge, for the plot event, I'm only pulling in columns I care about. So that's why it's like kind of long, where it's got the event ID, the plot name, plot number, cycle, X coordinate, and then the Richmond invasive species data. And I'm pulling in all of that, but I had already whittled it down when I did the group by and summarize. It didn't have all the columns in it. If you didn't whittle down the Richmond invasive species and you pulled in all of the plot event data too, you're going to have like a bunch of columns say like plot name X, plot name Y, plot number X, plot number Y. Because if you didn't use them in the by where you're joining them by, it's going to carry in a bunch. It just gets messy. So when you're doing merges, you generally just want to merge the columns that you care about and have them kind of unique to each data set. All right. And then the merging, I'm linking by event ID is really all I needed to do. That's what's going to join the tables correctly. But they also have plot name and cycle in common. So that's why I included them in the by equals, and then 3 of those. And then here it's a full join actually. So all X equals true, all Y equals true. So take everything from the plot everything from the invasive. If there are some that aren't in common, you still, want them all. And so that's where it's going to include species that don't, or sorry, include plots that don't have any invasive species this way. And then just to check that the merge worked, that's what the table is for again. So this table is going to summarize, it's going to have a row for each plot and then a column for each cycle and tell me if they've been sampled in that cycle. So that's just a way to kind of check that the merge worked. And then this is going to be easier when I actually show it in R so you can see what's going on. But when we did the merge, the plots that don't have any invasive species, they're going to have NAs in the Latin name, the species code, all of that stuff, because like there's no data to associate that with an invasive species. And so this is where in the invasive data, I'm taking average cover. Anything that is an NA that's average cover is not going to be 0. That's what I'm assigning to deal with the NAs. And then if you do this table complete cases for average cover, before you run it, it's going to say there's a bunch of NAs. And then after you run that, it's going to say there are none. So that's just to check how to do it. Okay, and then we make it wide. And then we save it to a shapefile. So it's a similar kind of at the end, similar to what we've done before. Any questions before I show it in code? No? All right, I will share my screen. All right, do you see my R screen yet?
Yep.
Okay. Great. So I'm gonna make my invasive or load my invasive table. So this is what the invasive list looks like. So it's got Latin name, common name, author, TSN, the guild that it's in. These were things that were useful to us for the trend analysis. And then MID and invasive, if it's not on the invasive list, like this is an entire list of all of the potentially invasive species we found across like 5 networks. If it's on the midden indicator list as invasive, it's a 1. If it's not, it's going to be a 0. And then we have the year added that we're going to use to filter on for this metric. And I'm just, the next kind of line is just to simplify it. So I'm taking the invasive list. I just want ones that are on the list and that were added in 2007. And then just select the Latin name. And so now it's still a fairly long list, but it's smaller and we can use this to filter on. So working with the data, I'm going to create the exotic species data. This is what the Quadrat data looks like if we haven't looked at it before. So the Quadrat names are here, and the 1 and 0 is whether it occurred in that Quadrat or not. Probably don't have to worry about that right now, but the average cover is often what we're most interested in. And it's by species, so like Japanese honeysuckle, average cover on this plot was 0.06, Oriental lady thumb, all of that. So that's what the data looks like. But again, there are species on this list that either were added later, like I think ligustrum was added later, or that we don't actually consider invasive. So that's why we're doing the filter. So we're actually making the filter list. And so we can actually look after running that filter. If you look in my global environment over on the right, The rich exo species had 193 observations. The invasive only and only species that were on the list from the beginning has 123. So we lost like 70 records. Just checking how many plots I lost. Now I only have 24. So there are like 8 plots that don't have invasives in Richmond. Right. Again, here I'm summarizing because I only want like one average cover value per plot, not for every species on a plot. So that's what this summarize for species 2 is for. And then again, we need to pull in the plots that don't have invasives. So that's what the rich plot Eve4 is for. And again, there are 32 plots. And we do our merge. So we're merging the plot data and visits with the invasive data. I'll show you what that looks like, and I'll show you what it would look like if I didn't clean it up first. So this is all the data we're carrying through. This is all we care about, actually. But if I did it's just messier. So so you can see, like, I only used the event ID as the key to merge with, even though both of these data sets have a cycle in it and both of them have a plot name in it. And so that's why we get plot name X that came from the left data set. Plot name Y came from the right data set. There's NA in here too, because there wasn't Richmond 317, apparently didn't have invasive species in it. So it carried over an NA for the right data set. It's messier this way. So that's why in the actual data set that I did, I only pulled in the columns I cared about in both data sets, but I had multiple keys that I merged by because both data sets have a cycle in it, both data sets have a plot name, and both data sets have an event ID. Cleaner. Hopefully that makes sense. So now let's just check that our merge worked. So here, a 1 means that there's a record of plot 15 in cycle 1. There's a record of plot 15 in cycle 2. Richmond plot 29 hasn't been sampled in cycle 4 yet. Like this is what we expect. So this is good. It carried in all of the plots that we want basically, and they have a record for every cycle they've been sampled in. So that's what that table is for, checking.
May I ask a quick question?
Yes, please.
What if for some reason in my cycle 1, I have a mysterious 0 in one of my plots and there's only 1 0?
It's possible because let's see, Gettysburg had a plot, I think, in cycle 1 that was rejected, and then a new plot added in cycle 2. And so that new plot will have a 0 in cycle 1. Yeah, there are a couple. Camilla, you probably remember them better than I do.
Yes. Are you looking at Get right now?
I'm looking at GWA.
GWA.
I don't remember GWA having that.
Yeah, I don't either.
Because it was, so in the park assignments tab in our gigantic spreadsheet or Google sheet that we're keeping track of everything, Gettysburg has in cycle 1 a plot that's missing. Colonial has a plot missing in cycle 2.
2.
And then Petersburg has a plot missing in cycle 1. So that would show up as a 0. But I don't think any of the others should be 0.
Which plot is it, Jamie?
214.
214, and it's in cycle 1.
Yeah.
Yeah, if you have.
Let me just check this.
Data sheets through the scanner and just, I mean, just.
Huh. There is a visit.
Put certain sheets in order by date, and the data sheet
It's got quad data.
the data sheet ones.
It doesn't have any invasive species.
Oh. Yeah, you know what? That must be what.
That's weird though, because Richmond you had plots without invasive species.
Yeah, let me look at the data. So I just like went back and added all parks, not just Richmond, so we can like look at this. What is it? It's counting cycle and plot name.
Okay, cool. Yeah, I just need this. Yeah,
Not pulling in cycle 1. Oh, let me do this. Okay, ignore what I did before, like just before. There is a, there should be a GWA 214 cycle 1, 2, and 3. It's going to be an NA for average cover, but we were just counting the number of cycle records. So when I actually did the code right and look at the cycle data for each plot, where was G at? Gettysburg has the 0 where we expect it, plot 356.
Mm-hmm. But GWA 214 is there.
Yeah. Yeah, so I'm not sure why that came out as 0 for you, Jamie. Should be there if the merge went properly.
Okay. I can fiddle around more. I don't know why only one plot would have a 0 in cycle 1 if the merge was wrong. I'd assume there'd be more, but that could also be a very much false assumption.
I mean, it's possible that you just missed the line that, turned the NAs into zeros. Like if you just make sure you go back and make sure you rerun every line. Like if you just happen to skip that.
Yeah, the table line though, it occurred before we changed average cover to NAs to 0. So I think maybe what might have happened is, did you do a table on the invasive data, not the merged data? Because if you did it on the invasive before you merged, it's going to say there's not a plot for 214 because it didn't have invasives in cycle 1.
I have table GWA invasive merge.
Okay, then it's possible that the merge wasn't correct. How about try just to double check. So this is, the data set that we're trying to merge to add all of the plots back. Again, this is everything. But like for me, when I do that, I get GWA being in the first cycle, 214. Do you get that when you run it? If you run this line?
Let me check.
one more second.
That's good.
Yeah, I get it for that line. That 214 has one. Yeah, I don't know. I can fiddle around with this more, and if I'm continuing to have this problem, I can also just ask later.
Yeah. Yeah, I mean, you can also like share your screen if you want, and we can try to see maybe where it might have gone wrong. Is it possible that in your merge you have all x equals false and all y equals true or something like that?
I think I just fixed it, so we're good.
Oh, okay. Great. Okay.
Yep.
All right, let me change this back to Rich just so I'm not confused. Okay, back to where we started. All right, this is where we look for, let's just look at our data set for a second. So all the plots that we pulled in that didn't have any invasives, their average cover is coming in as NA. We don't want NA, we want that to be 0. So another way to kind of quickly summarize how many NAs you have in a column or in a whole data set is the complete cases. And so it tells us there are 36 average cover column records that don't have a value. It's an NA. So to fix that, we are going to take our data set and our field, and this is base R subsetting basically. Oops. So basically what we're saying is we're interested in the average cover column. We're interested in all rows in the average cover column that are in A. We're going to change it to 0. And now if we rerun the complete cases, we go from having 36 that are false and 68 that are true to now having all as being true, because now they are 0. So now these 3 here, average cover used to be NA, now it's 0. Does everyone see how I did that?
Yep.
Okay. And I think there's a tidyverse way of doing this that is like replace values or something, or replace NA, I think is another function that you might be able to use. So there are multiple ways to do this. I've just gotten used to doing it in base R. So I do it that way. Okay, so I think the last step is this wide by cycle. So we're going to have a column for every cycle and a row for every plot. And because we're making this shapefile, we're taking our merged data set, just selecting the columns we care about, but making sure we have the XY coordinates so we can make it shapefile. We're arranging by plot name and cycles, so they're alphabetical in the data set that's returned, and pivoting wider. And so this is our data set that we're going to make into a shapefile. So cycle, zeros, and then, hold on. Plots that haven't been sampled in cycle 4 are still NA here. So I think it's worth mentioning here. So let me go back to where we added the 0 for NAs in the invasive merge. So the Richmond invasive merge data set only has like a record for a plot that has been sampled in a given cycle. And so we're adding 0 there because that's a meaningful, we didn't find invasives there. When we pivot wider here, because we're pivoting on cycle, we're basically like creating records for plots that haven't been sampled yet. And for those, we're not filling as a 0, we're letting it stay NA. So in the pivot wider, that's why we're not doing values fill equals 0, because we don't want a 0 for plots that haven't been sampled yet. Does that make sense why I did it in one place and not the other? Hopefully. The key is just to make sure you're not putting 0s where we haven't sampled a plot yet. Okay. So then finally, we're just making the shapefile. So that is metric 12 in a nutshell. Any questions? Okay. Metric 13 is cheating. So we're displaying this information in two places. We're doing it as a shapefile that we're going to plot on a map, but then we also are outputting it as a table. So the metric 13 is actually a table, kind of like what you did for the seedling and sapling table by cycle. And instead of like redoing all of that again, you either could have taken the rich invasive wide before you added the coordinates and proj4 string to it. So, here, it's going to tell me it's a list, or let's see, what is class going to tell me? So when I go to class for rich invasive wide, it tells me it's a data frame here. After I add the coordinates to it, it actually is a spatial data frame. So it's actually different now, even though it might look the same. It's a different kind of data set. And so you can't, after you've basically made it a spatial data frame, you can't write it to a CSV because there's a lot of stuff in it. Oh, it actually, it did. Let me just see what that ended up looking like. Oh, I guess you kind of can. I'll show you what that data looked like when I wrote it to CSV for a table. It just like carries stuff that you don't necessarily want. I don't know what that optional is for, but I guess that it worked. What I was gonna show is once you add coordinates and stuff to it, it's got all this other stuff associated with it, like the bounding box, proj4 string, because it's like a shapefile. Shapefiles have multiple files associated with them, including the DBF, which is like where the data is. And so for metric 13, if you've already done all of this to your rich invasive wide, the way to then write it as a the actual data table is stored here. So that's just what I was showing to save you time. Once you make it a spatial data frame, access the data or make changes to the data, you have to do this at data instead of, like, you couldn't do. Oh, it's fine. Okay, I thought it was pickier than that. So sorry. I think all you need to do for the invasive cover table metric 13 is after you've run all of this for metric 12, you can just do this, write that to your data set. So yeah, sorry, I thought it was more complicated than that, but I didn't test it.
Yeah, well, it doesn't let you like open it or like view it, I guess. Yeah, I always figured it was like locked down.
Yeah, right, because when you view it, it like shows all this other stuff, and so it's like, oh, I guess this is where the data is stored. It's in like it's called a slot, and so I thought you had to pull out the data, but I guess it's making decisions for you
That's
that I
cool.
didn't think it would.
Yeah. 'Cause I
Any questions? Because I think I was very confusing on that probably. Basically, if you follow the code, it'll get you what you want. Okay. Do you guys want to take a quick break and then do metric 14, or do you feel good? What do you want to do?
I'm down for a quick break.
Okay.
yeah, actually I have one
Take
more thing.
5.
Cool.
Okay. Anything come up during the break?
Got my COVID test back.
Oh.
I was negative on Thursday. So, did see my family though. So we'll wait for their test results. But yeah, but anyway, that's good.
Are you planning on getting tested again after coming out?
No. I think it's still apparently hard to get tests up here.
It is.
Yeah, so they're telling everyone to get tested before you come to Maine.
Gotcha.
Which, like, there's some obvious logical pitfalls there. But anyway, I think it's, risk reduction. Anyway.
Unfortunately, it still is pretty low incidence. I mean, it's hard to just like, there aren't like drive-through clinics to get tested or anything like there are in other states, but there is, I think, enough testing going on that we can trust that it's still pretty low incidence right now. Like there's not like community spread happening widespread, like, at a big level, at least we think.
Yeah.
But,
yeah, I think that it would become obvious if that was happening.
Yeah.
I mean, or, I think it does seem that, the strain that we've got going on is less lethal than it was at the beginning, which is good. But yeah, it's not harmless.
Right. I think it's also like they know how to treat it better.
That's also true.
And the ICUs aren't overwhelmed yet.
Well, they are in Arizona.
Right. And Florida in places. So, right. But at least in Maine.
Yes.
They're not overwhelmed yet, which won't take much if there starts to be an outbreak. Because what? Did you say there are like 20 ICU beds in Bar Harbor?
Oh, I
something?
thought there was yeah.
There's 60 something in Ellsworth, so there's more in Ellsworth,
better.
but it's still not very much when you think about the number of people that can be, in this area during the summer. That's very low. And I saw like a survey, it was either like 538 or New York Times or something that like listed the best states to get COVID in, and Maine was 49 out of 50. Yeah. Especially because like especially if you're in rural Maine, like the closest hospital is like Bangor if you're in Aroostook County. So like, yeah, the incidence is low, and that's a good thing because we're screwed if it's bad. It's basically what that came to. Yeah, I was kind of shocked. So
what's 50? Like Alaska or Hawaii?
I don't remember. Maybe it was Alaska. That would make sense. I think Montana was another bad state to get it in because there's just not
It's almost better to just drive to New York. Be like, oh, I'm not feeling good. I better just have somebody drive me down there.
Yeah, and at least in New York, they, especially like around where it was really bad, like they know more than any place in the country probably how to treat it. Whereas like, I don't know if I trust like my primary care physician to really, I think mine would keep up on it, but like every, Maine primary care physician to like really know the latest and how things should be treated, I don't trust that to be true.
Mm-hmm. So I hope the emergency room doctors they must be getting bulletins or something. I mean, I don't know, but like,
I hope so.
You gotta hope that they've got some stuff going on.
My dad actually works in a hospital. He's a PA. And when this first started, he had to like review how to do like the procedures to like help treat COVID in case he got sent down to the city. So I don't know if I would fully trust the New York hospitals just because they're kind of taking whoever they can get, even if they haven't, learned what to do in 10, 15, 20 years. So.
Mm-hmm. Yeah. So I'm glad your test came back negative. And yeah, at least now the incidence is still really low. And at least the place, I don't go anywhere other than like the grocery store these days. But when I do go to the grocery store, most people are wearing masks, at least at like Hannaford's or Shaw's. when I go to the smaller places, people aren't necessarily wearing masks. And so like John Edwards, just so you know, Camilla, is like a nightmare of just like people close because the aisles are really narrow.
Yeah.
They're not limiting people. And especially like during the farmer's market, it's just packed. Like I won't go there anymore during the farmer's market, especially.
Yeah, I would have thought they were like, well, I guess that it's not all. Yeah, I don't know. But they're
They're
like an
supposed to be
actual
good
food mart.
hippies. Yeah.
That's what I guess I would have thought.
But
Yeah.
they're not. Or at least they're not really enforcing anything. Maybe they are now that they can. I think, up until like a couple of weeks ago, businesses couldn't enforce face masks. I think now the governor gave businesses permissions to enforce that and to refuse business to people that won't. And so maybe John Edwards is doing it now. They weren't before.
Yeah.
So
you never know who you're gonna get though. The vast majority of people are, reasonable, but you might get some crazy person who's gonna like start coughing in your face or something.
Yeah. Okay. So back to invasives, maybe. Sorry, that was a digression, but I'm glad we talked about it, I guess. All right. So now, where am I? I walked you through, but I coded it, right? So now I need to talk about the next metric. Is that right?
I think you're on 14.
14. Okay. So metric 14 is invasive cover by species. So this is another composition one where it's going to be pies that have the species. And oops, haha. I was checking here to see what species were in Valley Forge, knowing that that's one of the most invasive species or invaded parks, to see how many you come up with. And then I forgot to change it back to Richmond, if you noticed that in the code. That's a glitch. I'm just going to fix that before I forget.
Is that why? Oh, wait, no, never mind. We'll get there.
Okay, sorry, I got distracted. So pretend on that first rich invasive pie that actually VAFO says Richmond instead. And this is just going to be the last 4 years because we're just plotting the pies for the last 4 years of data. And then we're using the make species code function again from before, just so it's easier to work with the data. And then just seeing what the top species are. That's what that first code chunk is. So it's basically the same kind of approach that we took with the region and the trees, but now we're working with the exotic quad data. And then I think so when I did this make species code and then that table, there were only like 10 species, on the list. And so I didn't actually have to group any further than that. It's possible for like VAFO or other parks, you might have to actually group, but this one I didn't have to. And I also, if you notice, like I didn't, because this is just the last 4 years, and the last 4 years the invasive list has been the same. I didn't actually filter on that invasive list we had before that only has species that were recorded from 2007 on, because for this one it's just the last 4 years it's been the same list all throughout. And then I also didn't use it to just pull in what we consider invasive, so like malice would possibly be on this list. I don't think you're going to come across examples where we need to filter, because this is in the quadrat data. In the quads, you're just doing indicator species, and so you're not going to have a bunch of random stuff, whereas the regen and the trees, it's like all woody species, except for maybe in 2019.
Yeah, that's the one thing. Are we accounting for 2019 having a vastly expanded species list?
So I I didn't in the code, obviously, because I actually ran it for all parks and I didn't see that being a problem because all the woody species that came in were native.
That makes sense. Yeah, I think that's
okay. But
right.
I maybe should add that in the code anyway, just to check. So when we go through it, I'll add it and then you'll see it on the website just to make sure because it's possible I missed something.
I think the one thing that might come in is like Elaeagnus, because that wasn't on. There's not a lot of it, but I think there's like one plot in Gettysburg, maybe, but maybe we haven't even done it yet. You know, like could be still to come in cycle 4.
Oh, okay.
But that's off the top of my list. That's the only like, you know, invasive woody that really wasn't on the list for some reason.
Okay, but yeah, let's just add it to the code just so it's a good safety check. I just yeah, I wasn't thinking about it. Okay. So yeah, this was pretty simple because at least in Richmond there were only 10 invasive species on the list. I didn't have to do any kind of grouping. But if you needed to do grouping, you follow kind of the workflow that we did for the trees and regen. And yeah, I don't even, I did a check of all the data and it didn't seem like I really needed to cover that. But if you do, you know, you could try to lump Liniceras possibly, or if there are, you know, a couple of species that only show up in one place, like wavy leaf basket grass, I think we've only found that in 1 or 2 plots maybe. And then maybe there's another species like Cardiomania impatiens, it's only in 1 or 2 plots. Maybe you lump those and just say like other exotic, and if you need to do that. And that may be more hard coding because it's not really genus level like we did with trees and regen. It's more just like the rare species, kind of lumping them if you need to.
Yeah. And I'd say if you do have that, like Gettysburg, it's quite diverse. So maybe you could have, instead of lumping Linus, because there's Linicer japonica and like the shrub Linicers are quite different. But maybe you can have like invasive herbs, you know, because we find that like in Gettysburg, there's like Glaucoma hederaceae, which is invasive, but like it doesn't really do all that much. Anyway, so there might be a bunch of little things. There's like Duchesnica indica, like the false strawberry. Like you could lump all of those guys together, and I don't think, you know, there just might be a whole bunch in Gettysburg. So much fun.
Yeah, that's a good point. In general, probably the herbs are less interesting than the individual shrub species and vine species. So yeah, okay. So I guess I could probably just start coding this because it's pretty straightforward in the website. Okay. Forget, just out of curiosity. I'm going to be lazy here. You can usually pipe along with the functions in the 4sim IDM package. So I just made the species code that way instead of making a separate line. So yeah, the species code is in the data. So now let's do the top species to see what's actually in there. Okay, this is the top species in Gettysburg. So yeah, there's 19 species. It looks like there's 3 Elaeagnus, either spa, umbellata, or angustifolia. So that might be one that you lump in Gettysburg. Linus japonica for the win, so that you'll probably want to keep on its own. Microstegium, Rosa multiflora, Berberis. Okay, so probably down to like Ribosphena colossius. Those are probably all good ones to have on their own because they're pretty common. And then the others, like Linicera, and then the dash, that's Linicera exotic. So that's the shrub instead of the vine. I should maybe fix that species code coming in. And then there are some like Persicaria, Perfoliata, that's Milominate. That's kind of a big early detection species that parks are really concerned about, but it's only in 2 plots, and so it may be one where you just have to lump it. I think using an early detection list, which actually Gettysburg doesn't have, but kind of using the species that are high priority to leave on their own, even if they're rare, is useful. And then the ones like, what is it, Duchesnea indica, like Camilla said, that's actually not really invasive. This is one where I think it makes sense to just pull out the invasive species. So that's where the invasive list, let's actually view the invasive list. Let's see if Duchesnea, I don't think we considered Duchesnea invasive in our analysis. Yeah, it's actually not even on the list because we don't consider it invasive, it's just exotic. So it will make sense to filter on this. And this is doing kind of the same thing we did in the regen and the trees, where we filtered on the species that have always been on the list. Where was that? Oh, did I not do that yet? Oh, sorry, I'm in the wrong metrics. Here we go. So for that metric 12, where it's the bar charts over time, where we filtered the mid-end list. We're going to do the same thing, but we don't care about year added here. So again, look at the invasive list. I need to make a new list. Sorry. So this is the last 4 years invasive list. So let's look at the top species again, but for this shorter list. And now I think Duchesnea should be off the list. Yeah, so it's a smaller list now, it's just 14. So we dropped the species that we don't really consider to be super invasive, but we still have more. And I guess Elaeagnus never made it. Interesting, maybe we don't want to do that. I'm sorry, I'm obviously haven't thought this out as thoroughly as I should have.
Right, I guess you lose the new things we're picking up.
Yeah.
I think it's fine to just lump like other like exotic herbs or something.
Herbs. Okay.
You
Yeah,
know.
let's do that. So let's go back to the top species where it was before we filtered the list. And just this is where it's like more doing it by hand than logic. So let's say we want the invasive herb list. This is doing the work by hand. So let's say Duchesnea indica. Per maybe. Let's say invasive shrub. Or let's do, how about?
Well, did we want Persicaria defoliata on its own?
Yeah, I guess we can do it on its own.
Uh,
Just trying to think, like, you know, looking at this list.
Yeah.
The Elaeagnus makes sense.
Persicaria longicida, you should dump or put it in with Duchesnea.
Is it on here? Oh yeah, good. Okay.
That's like Oriental lady's thumb. You guys familiar with that one? Like it's just kind of everywhere. You could lump the Elaeagnus.
Yeah.
I don't think I really figured out how to tell them apart, honestly. So this is better.
Should probably put these scripts up higher than my actual script.
And I guess there's always garlic mustard.
Yeah, let's add garlic mustard to the invasive herb one.
Yeah.
There's a lot of it, but it's been around in some of the parks for so long, they're less like, what were you going to say, Camilla? Sorry.
Yeah. Well, we're not even really getting a proper like cover on it because it's by the time we get there, it's mostly Senesced anyway. So we're missing probably 80% of it.
Okay. Okay, so Dioscorea and Celastris are both vines.
Mm-hmm.
There's
Dioscorea is kind of herbaceous vine. I don't know. Yeah. I mean, what are you down to in terms of categories now?
I think I have like 13 now, so I might want to. So we could lump Acer platanoides and Ailanthus as other tree, like invasive tree.
We could, yeah. I mean, this is all like personal preference. I feel like Dioscorea oppositifolia has like a smaller impact than like Ailanthus and Acer platanoides.
Okay.
I don't know. I mean, it doesn't seem to be a big player, whereas I think that people do know Tree of Heaven and Norway maple.
All right, I'll do that. Another vine I should do, or I could just do invasive woody.
Well, yeah.
And add.
But then you'd have to put Lonicera in there. What about, I don't know, do you think it'd be totally wrong? Sorry, we're really getting down the path now. But is Dioscorea oppositifolia, isn't that sort of an herbaceous vine? Could you throw it in?
No, the Villosa, the native one, is
the native
more
one.
herbaceous,
Okay.
But I always think of oppositifolia as like when you see it down in like Florida, it's super woody.
Oh wow. Okay.
Crazy.
Yeah, I've never seen it that way, but yeah, that makes sense.
And there's only one of it, so.
Right, that's why. Yeah.
Let's see. I mean, we could euonymus, put that one in, that also invasive woody. So we'll have like an invasive herb, an Elaeagnus, an invasive woody. Let's just see how we end up.
Yeah. Right. This is like other invasive woody category, basically.
Yeah.
Okay. That makes sense to me.
Just looking to see, but we can leave Linistra shrub on its own.
Mm.
These are our groups, and then there are other. Let's see. All right. So now I'm going to try to do the case win thing. I just need to make another column. Then we'll find out if we need to whittle down more. And then anything that's not in that group is just going to get its species code pasted.
Kate, before the paste 0, is there a difference? Are all of those little squiggly lines, or is there one or two that are just straight lines? And is there a difference?
Oh yeah, they are squiggly lines. If it was a straight line, it would be minus. So you'd be subtracting. Like R always sees a straight line as a minus.
Okay.
This is saying like the squiggly line in the tidyverse is often like apply this function to it, or like apply this thing to it. That's how they're using it. So in this case, when the first line says if the species code is in that invasive herb list that we just made, then you'll want to do this action, which is paste invasive herb into my species group column.
Okay, thank you. They just kind of looked like there was a mix of them on my screen,
Oh,
so
yeah,
I wanted to make sure.
zoom into my code. I can make my text a lot bigger. Sorry, I should have thought of that earlier. Is it clear that it's a squiggly line now?
Yeah, thank you.
Okay, I still have a lot of groups in here. With 13. So this is where it's like, we might want to, I guess we could take the Elaeagnus and put it in the invasive woody. That would take us down. And there's only 3 in there. So let's do that. There's still like 13. So I don't know, Camilla, do you think putting Nori Maple and Atlantis together is good, or would you
What
prefer the Linicera going in invasive woody?
Oh gosh. I can't actually see your. Can you like move the control for like the video call or like in front of the of the table?
I don't think that's on my
Is that
end.
me? I can't get it to go away.
Oh,
It's very annoying.
what if I? Whoops. Here. Does it show up now?
Yeah.
Okay.
Yeah, thanks. Yeah. Um.
I mean, I guess there's 12.
Yeah, I guess there's. Yeah, I guess it's just for this park because there's so little Ailanthus and Acer platanoides. Because yeah, the mile a minute they're managing, so we'd want it to show up. Maybe it's even maybe the Linicera exotic, the shrub, could throw into. It's just the lawn jack is so omnipresent. I feel like that's like the most common.
Yeah.
So I want to leave that out, and it's in terms like regionally, there's a lot more Linicera japonica than there is like bush honeysuckle, which is sort of the opposite of what you find in NETN. So I guess I'd want to keep that out, but the bush honeysuckle is not really that common.
Okay. Yeah, so I lumped it, and I think for like the region and the trees, because we're going to be kind of coordinating a little bit across there, having 12 groups is fine. We may find having 12 invasive groups is actually a bit much, and so we might like it's going to be iterative, I guess. You're going to have to kind of figure it out.
Yeah.
And color coordinating the species across the parks is going to be challenging. I think for the ones that are most common, like Microstegium, Linicera japonica, Ailanthus, multiflora rose, and probably Rubus phoenicolaceus, those are ones that we're going to want to be the same color, probably in each park. But then you're going to have, color combinations unique to a given park just because they're different species. Yeah, I mean, we could try to color coordinate if we want, but we may end up having to just like maybe 80% of the species have a unique or like the same color throughout, and then like another 20 are unique.
Yeah, I think we could probably do it pretty well. Like, I mean, we can have those species that you listed that'll be like very, common throughout. And then if we color code like exotic herbs and then like other woodies, and like those can always be the same, and then we'll just have like a couple floating colors for like the rare species maybe, and hopefully that'll get us most of the way. But there will definitely be less, like once we figure out the colors for, I think basically the region and the tree stuff I think will be more complicated. There's not as many exotic species, hopefully, once we get the groups down. Kate, you're muted if you're saying anything.
Thanks. I was saying something.
I thought you were suspiciously quiet.
Okay, so what I was saying is I actually changed the join quad data to all parks just to see the top list for the whole network of data. And it is true, Microstegium is the big winner. Linicera japonica is the next one. So we do have, there are like 12 species that are pretty common throughout. And then you got a bunch of stragglers. So like glaucoma that Camilla mentioned earlier, Linicera mackii, Oh, and here's the wavy leaf basket grass in one plot. So I think coordinating these species so that they're the same color throughout will be useful. But once you start dealing with some of these that are only found in one plot in a park or only found in one park, those are the ones that we might just have to have kind of some colors reserved for the miscellaneous species. Okay. So let's see, where am I? All right. Did I need to go back and make this Gettysburg again. Okay, I'm gonna pick up where I left off. Yeah, I actually skipped a couple of steps in my code. So now I have the groups that I want, but they, like if there's Dioscorea and Celastris on the same plot, they're gonna come out as being multiple records, so I have to summarize before I can pivot wide. This is a step we did in the regen data and the tree data, but I didn't include it here, and I should have. Species group. Make sure this comes through. This is what we're going to pivot wide. Now I can do the pivot wide. Oops. Sorry about that. I don't need to do the select because I think I have all the fields I want. Here we do values fill equals 0 because all of these plots in the last 4 years have been sampled. And so if there's a species that it hasn't been found out, we want it to have a 0. Oh, but right, it's not species code, it's species group. Okay, so this is what it looks like, and then you make it a shapefile. Let's just view it. So yeah, Acer platinoides only showed up in one plot, but it's all right. Oh, you know what? Sorry. Before the pivot wider, I want to arrange by species group so that the columns are in alphabetical order, just so it's neater. now they're in Acer Platinoides, Ailanthus, they're in alphabetical order. There's a lot of microcegium. Wow. Okay, so then we make that a shapefile. All right, so that was the more honest way that looks versus what I showed you for the trees and regen, just because I had more logic. But yeah, that's where you have to be a little iterative. Any questions? No? Okay. I think I'm gonna stop sharing my screen. I will update the code after we're finished here with what I just did for Richmond, but like what we just did for Gettysburg, so that you can see that process. And I'm sorry, I kind of skipped through it. I didn't need to do it for Richmond. And so I was like, oh, I don't know if I'll actually need to do this for any of the parks, but it turns out, at least in Gettysburg, probably in Valley Forge, we might have to. Okay. Do we want to talk about the invasive species plot frequency? That's metric 15 now. I'll stop sharing my screen. Okay. So let's see. So this is a table. It's similar to like the seedling and sapling table you guys made, but this time it's invasives. But instead of having a row for each plot in what we found, it's a row for each species and how many plots it occurred on. So we're going to take the invasive list again, and this is where we're going to help show which species have been added over time. So the people, like we're, you know, in one map, we're kind of removing any chance of showing that, but it is nice to be able to show which plots we found, like wavy leaf, or if we found wavy leaf basket grass anywhere. So that's just what we're doing. So the first line is to pull in the invasive list again.